So next, we are going to look at the component of the power generator, okay, or the basic component of the power generator. So the generator is made up of two major components. That is the engine, which is the part that converts whatever form of energy that is sent into the station into rotating mechanical energy. And then we have the alternator. The alternator is the part that now converts the rotating mechanical energy into electrical energy. So, like we said, the engine is the prime mover, as you can see on your screen. That is a reciprocating engine. Could be diesel driven or gas driven. So this is the part that converts, as we will see later, that converts the chemical energy that is contained in fuel, okay, or in the diesel or in the gas into rotating mechanical energy that is transferred into the crankshaft of this particular reciprocating engine. Now, we also have the alternator. Like we said, the alternator is the part that converts the rotating mechanical energy produced at the crankshaft of the engine, okay, into electrical energy, because the crankshaft is coupled to the rotor of the alternator, and then the alternator, the rotating mechanical energy is transferred into the rotor of the alternator, and then the alternator converts that rotating mechanical energy into electrical energy that is fed out of the alternator. So now let us look a little bit in details the various types of the prime movers that we have in the power stations. And then we'll see briefly how they function, how the components of those prime movers, how they interact and produce the rotating mechanical energy that is so needed by the alternator. And then we'll also look at the alternator, how it converts the rotating mechanical energy into electrical energy that we actually need in that is from the power station. Now let us look at the gas turbines. The gas turbine, basically what it does is that it converts the chemical energy that is contained in the gas, methane gas principally, into rotating mechanical energy. So how does the gas turbine does this? If you look at the configuration of the gas turbine, you will see that it has two major sections, okay? Though it has three sections. It has a compressor section and the turbine section, and also the combustion section, okay? So now what happens is that in the compressor section, air is drawn into the turbine through the compressor section, and then that air is compressed in that compressor section. And that compressed air will now be sent into the combustor. In the combustor, fuel is injected into the compressed air. So the mixture of this compressed air and fuel is ignited in the combustor. So the ignition product, which will eventually have a very high kinetic energy, okay, will now be sent into the turbine section by the transition piece. So as it goes into the turbine section, there are blades in the turbine that helps to extract this kinetic energy that is contained in this high energy combustion product, okay, into extract the energy from it and convert it into rotating mechanical energy. So we'll see how it does so later, okay? So that is the turbine that you can see on your screen now. It is open. So this is the compressor section, and this is the turbine section. So this is the rotor of your turbine, okay? This is the rotor running from the compressor end to the turbine end. So now what happens is that air is drawn into the turbine through this intake plenum, okay? So the air goes into the turbine through the plenum and then to the compressor. So in the compressor, you will see that the air is compressed at the compressor and then sent into the combustion chamber. So here in the combustion chamber, you can see the fuel lines. Fuel is injected into that compressed air. So that fuel air mixture is ignited, okay? So as it is ignited, it burns up, and the combustion product is usually having a very high energy content, okay? So that high energy combustion product is now channeled through the transition piece into the turbine. These are the turbine blades. So as the fast moving combustion product is made to impinge on the turbine blades, okay, the kinetic energy that is contained in that fast moving combustion product is now extracted by the blade and then forces the rotor to turn the way your fan normally turns on being impinged by fast moving air, okay? So that is what happens around the turbine blades here. The turbine blade now extract that kinetic energy and converts it into rotating mechanical energy. So the turbine shaft will continue to turn as long as that hot combustion product comes in. And then once the energy is extracted from that much energy have been extracted from, okay, the combustion product with less energy will now be exhausted through the exhaust of the turbine, okay? So now you will see that what we have succeeded in doing now is the conversion of the chemical energy that is contained in the fuel into rotating mechanical energy. So this shaft, as you saw in the earlier, in this diagram, you see that the alternator is attached to the shaft by this gearbox, okay? So since it is attached to the shaft and since the chemical energy in the fuel has been converted into rotating mechanical energy, this alternator rotor will start to do what? To rotate, since it is coupled directly to this gearbox, which is in turn coupled to the shaft of the turbine. So next, we want to also look at the steam turbine. The steam turbine is another very simple but complex machine. So what happens is that steam is generated at the boiler. So that high energy steam, okay, first, the chemical energy that is contained in the fuel, okay, is liberated by combustion, and that heat is absorbed by water, okay, which means that the chemical energy that is contained in the fuel is first converted into heat energy, and then the heat energy is what will now be converted into the kinetic energy in that fast moving steam, because as the water in the boiler absorbs the heat, it will now evaporate to form steam. And as you heat further, that steam will gain more energy, okay? And then for it to move downstream. So that high energy steam is what is sent into this turbine, okay? So as it comes into the turbine, it spreads to both the left and the right, and then the high energy steam impinges on the blade, okay, the rotor blade of the turbine, and forces it to turn. So as it's turning, the shaft also will be turning, okay? Then one end of it is coupled to a gearbox and then to your alternator, as in the case of the gas turbine. So the next that we are going to look at is the diesel engine. The diesel engine, basically the same thing happens. Conversion of the chemical energy that is contained in fuel into rotating mechanical energy. So how does it do this? So as you can see, this is the combustion chamber, okay? The fuel is injected into this combustion chamber. And then if it is the compression ignition engine, the fuel is compressed until it is ignited. So once it is ignited, that combustion product, high energy combustion product, forces the piston, okay, to move down. So as it's moving down, that translational motion is converted into rotating mechanical motion by the crankshaft. So at the other end of the crankshaft, that is where our alternator is coupled. So you see that the diesel engine, its major function is to provide that rotating mechanical energy from the chemical energy that is contained either in the gas or in your diesel. So we also have gas engine. So in this case, it's the same thing, it's a reciprocating engine as we have here. But in this case, instead of burning diesel, it is burning gas, majorly methane gas. Okay, so the principles, they are the same. So it converts the chemical energy that is contained in that gas into rotating mechanical energy, following the same principle. Okay, the combustion product forces the piston to turn, to move translationally. Then that translational motion is converted to rotating mechanical motion by the crankshaft. Then the other end of the crankshaft, that is where we now tie our load or our alternator to. So that is how, these are the various types of prime movers that we can see in the power plant. And we also have other types too. We have the hydro turbine, like we said earlier. The hydro turbine, it converts the potential energy that is contained in dammed water into rotating mechanical energy. Okay, so that dam water, as it is released and made to drop from that height, converting that potential energy into kinetic energy, it drops on the blade of the turbine and forces it to turn. So as the blade is turning, you see that the kinetic energy in that dropping water has now been converted into rotating mechanical energy. So it is that rotating mechanical energy that will eventually be converted into electrical energy by the alternator, which is what we actually need from the power station or the power plant. So we also have others that converts the kinetic energy that is contained in fast moving winds, that is the wind turbines, into rotating mechanical energy also. Okay, so like in the other cases, that rotating mechanical energy will eventually be converted into electrical energy.